All right, so you know how we're always up for a good deep dive, right? This one's special. Someone sent us this JavaScript thing
Mm-hmm.
called Powering the Alarm Clock. And honestly, my brain's kind of buzzing about it, you know?
Oh, I bet. Especially when you consider where it's coming from.
Right.
This isn't just some random game site.
Hmm?
It's hosted on a whole website for open educational resources.
Oh, wow.
Open source physics at Singapore, to be exact.
So right off the bat, that tells us
It's serious stuff.
this is like legit learning territory.
Exactly.
Okay, so before we get all philosophical,
Sure.
what does this powering the alarm clock thing even do?
So basically, it's a simulation.
Okay.
You play around with different parts, like you got your batteries, your wires, and obviously the alarm clock.
Makes sense.
You can actually see how the electricity flows.
No way.
Makes the whole circuit come alive.
That's awesome.
Yeah, and get this, the source material. They give you the code
Oh, really?
to embed it on a web page.
Like anyone can just put it on their site.
Yeah.
Yeah.
With this HTML thing, an iframe tag, have you heard of those?
I know a little HTML, but iframes, honestly, kind of lost me.
They're super cool, basically. Like
Yeah.
a window to another website right there inside the one you're on.
Whoa.
So a teacher could pop that simulation right into their online lesson.
No downloads or anything.
Nope. Makes it super accessible.
That's really smart.
Right.
And it ties into that whole open educational resources thing, right?
Absolutely. OER.
So for our listener who's obviously like a learning enthusiast, what's the big deal with OER?
It's all about freedom.
Oh, cray.
Educational materials, anyone can use them, change them, share them.
So not like those pricey textbooks
Cool.
that get outdated so fast?
OERs, they evolve.
Wow.
A whole community of educators, experts always tweaking them,
That's incredible.
breaking down barriers.
Just everyone, right?
They're everyone.
It's like, imagine you've
Yeah.
got this constantly updated library, global, free, at your fingertips.
Exactly. And you're not just reading.
Yeah.
You can contribute, remix, share your own ideas.
That changes everything about how we learn.
Right. It's a revolution.
Makes you wonder how effective these simulations are compared to,
Traditional teaching.
Right. I mean, the source mentions sample learning goals, even a section for teachers.
Uh-huh.
What do you think they're aiming for with a simulation like this?
Even without seeing the specifics.
Yeah.
I'd bet they're trying to make things like electricity, circuits, more hands-on, engaging.
Instead of just words in a book.
Exactly. You're seeing the electrons flow.
Oh, wow.
How changing the voltage affects the bulb.
That's so cool.
Way more exciting than just reading definitions.
You're not just memorizing.
You're understanding.
And that sticks with you.
For sure. And don't forget, this isn't just some abstract physics thing.
Right.
Electricity, magnetism, these are fundamental forces,
They run the world, literally,
from our gadgets.
to the universe itself.
So understanding them, it's like understanding how reality works.
This is where I geek out.
How I know.
They have this other resources section. It's wild.
I saw that.
Antibiotic resistance dice simulation, due to math,
Mm-hmm.
even an amazing pendulum wave effect JavaScript model.
It's like what?
What connects these random topics to physics and simulations?
It shows how simulations can be used for anything.
Not just science.
Imagine that antibiotic one
Yeah.
could be showing you how bacteria evolve, using dice, game stuff.
Making it fun to learn about.
Exactly. Instead of just reading, you're playing, experimenting.
So cool. And due to math, maybe that makes math less scary.
Makes it visual interactive.
We went from alarm clocks to antibiotics, now pendulums.
I know. It's amazing.
What's the pendulum doing here?
It shows that everything's connected.
Oh, I like that.
Pendulums, they show you oscillation, harmonic motion.
And wait, relates to electricity.
In a roundabout way, yeah.
My mind is blown.
Mine too.
And their popular tags section, the top one is fractions of a whole one.
Interesting, right.
Seems odd next to electromagnetic induction and nuclear.
It's telling us
Is
even
that?
basic stuff like fractions.
Yeah.
They're the building blocks for those complex topics.
So you got to master the basics.
Before you can dive into the deep end,
Love that analogy.
it's catering to everyone.
All levels of learners.
Exactly. And then there's the translation section,
Oh, yeah. What's that about?
making learning accessible globally.
So anyone, anywhere, can learn in their own language.
That's the goal.
Powerful stuff.
It's about removing barriers.
Not just money, but language, too.
It's about inclusivity.
So everyone has a chance to learn.
Exactly.
Wow, we started with this powering the alarm clock thing, and now we're talking about a whole revolution in learning.
That's how deep dives go.
It's like, what are the big takeaways so far?
A simple simulation.
Can spark a whole world of learning.
Open educational resources.
Breaking down barriers.
And technology.
Is changing how we learn, making it more interactive and accessible.
For everyone.
And this is just the beginning. I feel like this deep dive is about to get even more...
It is.
Yeah. Exploring the future of learning, how simulations could change education.
We've got a lot more to unpack.
Oh, we got to save it for part 2.
Stay tuned.
This conversation is far from over.
Definitely not. Welcome back. Picking up where we left off, at the end of part 1.
Mm-hmm.
You got me thinking about the future.
Of learning.
Yeah, like as these simulations get even more, I don't know.
Advanced.
Advanced, yeah. What could that mean for education?
Okay, so paint me a picture.
Imagine this personalized learning.
Whoa, like tailored to each student.
Exactly. The simulation adapts.
To how you learn best.
Your pace, your style, everything.
That sounds incredible, but how would that even work?
Okay, say you're in this simulation
Mm-hmm.
and it notices you're stuck.
Oh, like I keep messing up.
Maybe you keep getting the same question wrong or...
I hesitate on certain things.
Exactly. The simulation could then adjust.
So it gets easier.
Or harder, or maybe it explains things differently.
To match how I learn.
Exactly. It's like having a personal tutor.
Built right into the program.
Think about subjects people struggle with.
Like physics.
What if a simulation could make that feel easy?
Mind-blowing.
Right. And it goes beyond just you, individually.
Oh.
Simulations can help people learn together, too.
I'm picturing like a study group, but virtual.
More than that.
Yeah.
Imagine a virtual world, you and other students.
Okay.
You're all in this simulation experimenting, talking, debating.
Oh, wow. And these could be people from anywhere, right?
Across the globe, sharing ideas, learning from each other.
It's like a global classroom.
A global
Where
laboratory.
everyone's working together.
Solving real-world problems.
This is getting me hyped.
And get this. What if we add VR? Augmented reality.
Whoa, hold on. VR in school. Now you're talking.
I know, right?
But I can't even picture it.
Put on a VR headset. You're inside a human cell, seeing how it works.
Whoa.
Or use AR to overlay diagrams onto your own body.
So you see your organs like in real time.
Exactly. You learn by actually experiencing it.
Okay, that's next level stuff.
I know, right?
But wouldn't that be super expensive? VR headsets and all
That's a fair point. But technology usually gets cheaper over time.
That's true.
Plus, think about all the money we spend on textbooks, labs.
Yeah, good point.
VR and AR might actually save money in the long run.
So we've got personalized learning,
Global collaboration.
immersive VR experiences.
It's a whole new world of learning.
My brain is already overloaded.
I've one more thing.
Hit me with it.
What if, as these simulations get super realistic,
Yeah.
they start changing how we think about knowledge itself?
Okay, now you got to explain that one.
We usually think of knowledge as facts, right?
Yeah, stuff you just got to memorize.
But simulations, they show you how complex systems work.
Like how everything's connected.
Exactly. You see how changing one thing affects everything else?
So knowledge isn't just static, it's dynamic.
It's constantly changing, evolving, and that's crucial for today's world.
Makes sense.
It makes you think, if simulations teach us to think this way,
Yeah.
will they change how we solve problems in real life too?
So not just revolutionizing education, but
Changing how we approach everything.
research, politics, even everyday choices.
Exactly. It's about the impact of this tech.
On how we learn, think, and shape the world.
You've got it.
We've focused on the good stuff, but
Yeah.
are there any downsides to simulations? Risks we should be aware of?
That's a smart question, and yes, there are.
Like what?
Think about bias. Sometimes it gets built into algorithms.
Oh, so even a fancy simulation could be misleading.
It could. Or some people might use simulations to spread misinformation.
So we got to be careful, not just believe everything we see.
Exactly. Critical thinking is key, especially in this digital world.
Always question, always evaluate.
Couldn't have said it better myself.
It kind of brings us back to why things like open educational resources are so important.
Oh, tell me about it.
Free access, so everyone can learn.
And question and understand the limits.
It's about giving everyone the tools.
To be smart, critical thinkers.
In a world that's getting more and more complex.
Exactly.
I love this conversation, but you know what? I think we're nearing the end of part 2.
Already. Time flies when you're having fun.
It does. But don't worry, we've got one more part to go.
And I have a feeling
Yeah.
it's going to be a good one.
Okay, last leg of our deep dive, and you left us hanging.
Right.
About those downsides of simulations. We got to talk about that.
Absolutely. So we're all about simulations, the potential.
Mm-hmm.
But we got to be real. As they get more, I don't know, sophisticated,
Yeah.
like hyper-realistic, there's this question we got to ask ourselves.
Shoot.
Are we maybe blurring the lines?
Between what?
The simulation, the virtual world, and the real world?
Like getting so sucked in we forget what's real?
Not quite, but how do I put this?
Yeah.
These simulations, they might start to, I don't know.
Change how we see things.
Yeah, like our perceptions, our expectations of reality.
Oh, I see what you mean.
If we're always in these perfect simplified worlds,
Right.
will we be ready for the real world? With all its,
Messiness. Unpredictability.
Exactly.
Simulations are amazing tools.
Absolutely.
But they're not perfect.
Nope.
They're always going to be like limits, things left out, maybe even some bias.
For sure.
So we got to be aware of that.
It's crucial.
Otherwise, we might think, oh, I can control everything, predict the future.
Or get disappointed when things don't go perfectly.
Like in the simulation.
Exactly.
It's about balance, right? Use these awesome tools, but don't forget real life, even if it's a bit messy.
That's the key. And this is where, open educational resources, they become so important.
Oh, right. Because everyone has access.
They can learn, critique, see those limitations.
So it's not just blindly trusting the simulation.
It's about being smart, being critical.
And that's crucial, especially now with all this technology.
Couldn't agree more.
So democratizing knowledge.
Giving everyone the power to learn.
And think for themselves.
Exactly.
Wow, I think we've reached the end of our deep dive.
Time flies.
Huge thanks to you for breaking all this down.
It's been a pleasure.
And to our listener.
Thanks for sticking with us.
We hope you learned some cool stuff.
About simulations, about learning.
And about that amazing powering the alarm clock thing.
It all started with an alarm clock.
Remember, keep that curiosity going.
Keep asking questions.
And keep diving deep.
Until next time.
See ya!